Hi everyone, welcome back to Lulumath. This video is on factoring by grouping, and in order to be able to factor by grouping, the background knowledge that you need is you need to know how to multiply a binomial by a binomial. So you can either FOIL or you can use the geometric model. Both of those videos are available, so check them out if you need a refresher. You will also need to know how to factor by GCF. Make sure to check out that video as well if you need a refresher on that. Now I want to expand this binomial multiplied by this binomial, but I'm not doing this to teach how to expand, but I'm using it so that we can understand what it is that we are doing when we're factoring by grouping. If you remember, when we're multiplying binomials by binomials, you just are going to take the first term in our first binomial and you're going to multiply it through to everybody in the second binomial. So this will end up looking as follows. So you'll have this 2x being multiplied through to this 3x minus 4. But if you're going to do that with the 2x, you also have to do it with this 3y. So this 3y is going to get distributed through to this 3x minus 4. And there's a very specific reason why I wrote this all out as opposed to just using FOIL. So multiplying this 2x through, I would get 2x times 3x, which is 6x squared. Then I would get 2x times negative 4, which is negative 8x. I'm done distributing the 2x through because my brackets or my parentheses have closed. Now I'm going to distribute the 3y through. 3y times 3x is 9xy or yx. It doesn't matter what order you put the variables in. And then 3y times negative 4 is negative 12y. There are no like terms, so this is my expanded expression. But I want to talk about how do we get ourselves back to the original problem? How do we factor back to our two binomials being multiplied together? Well, if you notice our terms written in orange, what I will do is I'm going to look and see, is there anything in common between those two terms? And there is. I can divide 6 and 8 both by 2, and then they have x's in common, and so my GCF will be 2x. So if I were to factor out the 2x from both of these two terms here, when I factor out 2x from 6x squared, I have 3x left over. And then when I factor out 2x from negative 8x, I have negative 4 left over. Then I'm going to do the same thing for this set of terms that we have here. So again, I'm going to look and see, well, what's the GCF? Well, 9 and 12 are both divisible by 3, and then they both have a y in common. There isn't an x in common, just a y, so my GCF is going to be 3y. So since it's 3y, I'm going to write plus 3y right here. Well, when I factor out a 3y from a 9xy, I end up getting 9 divided by 3 is 3, and then xy divided by y, the y's divide out to give me 1, or they cancel out, so I have an x left over. And then here, negative 12 divided by 3 is negative 4, and then y divided by y is 1, so negative 4 times 1 is just negative 4. Is this looking familiar? Well, it should, because this expression that we have here is what we had when we expanded this expression out here. Okay? One last step that we have to do to bring ourselves back to the original binomial multiplied by the binomial. So it's important to note that this right here is considered a single term because it's 2x times a full quantity. And then this right here is considered a single term as well because it's 3y multiplied by a quantity. So if I were to look and see what I have here, I have a 3x minus 4 in common with both of my terms here. So that's another GCF that we have here. So I will factor out this 3x minus 4 right here. When I factor it out of my first term here, the 3x minus 4 and the 3x minus 4 cancel, and I have a 2x left over. And then when I factor it out of this term here, the 3x minus 4 and the 3x minus 4 also cancel out, and I have a 3y left over. So if you notice, this is exactly the same thing as what we had originally here, except the 3x minus 4 is first and the 2x plus 3y is second. But the order doesn't matter because the multiplication is commutative. And this is what it means to factor by grouping. I grouped two sets of terms together. I found their GCFs, I factored them out, and then by doing that, I end up getting my two binomials being multiplied together. All right, so let's go ahead and try it in our first example here. So we're asked to factor 4x squared plus 9x plus 8xy plus 18y. I'm going to see if I can group my first two terms together and if I can group my last two terms together. So if I look at my first two terms, what's in common with 4x squared and 9x? Well, 4 and 9 don't have anything in common, but we do have an x to the power of 1 in common. So I'm going to factor out the x, and when I factor out an x from the 4x squared, I end up getting 4x. And when I factor out the x from this 9x, I end up getting plus 9, okay? Then I'm going to look at my second group right here, and I see 8xy and 18y both have a 2 in common, a positive 2 in common, and they also have a y in common. So I'm going to factor out a 2y. Well, when I divide 8xy by 2y, I end up getting 4. The y's will cancel out, and I have an x left over. And then 18y divided by 2y, 18 divided by 2 is 9, and again, my y's will cancel out. So if you see here, we have a 4x plus 9 in common with both of our groups here. So I will factor that out. So I've got 4x plus 9 here, but when I factor out a 4x plus 9 from my first group, then I will end up having an x left over, because the 4x plus 9s will cancel out. And then if I factor out a 4x plus 9 from my second group, the 4x plus 9s cancel out, and then I have a 2y left over. And this is what I get when I factor by grouping. I just want to point something out that will help you out as well when you are factoring by grouping, and that is that sometimes you might have to change the order of your terms in order to be able to factor by grouping. So for example, if you see here, I have this 4x squared and this 8xy, they have common factors. So I'm actually going to group those guys together. So 4x squared plus 8xy, I'm going to put them together. And then if you see here, I have 9x and 18y. Those two have a GCF as well. So I'm going to group the 9x and the 18y together instead. So looking at my first group here, they have a 4 in common. They're both divisible by 4, and they also have an x in common. So when I factor out a 4x from 4x squared, I have one x left over, or just x, okay? And then when I factor out a 4x from 8xy, 8 divided by 4 is 2, the x's cancel, and then I have a y left over. Now, looking at my second group that I have here, 9x and 18y are both divisible by 9, so my greatest common factor is 9. When I factor out a 9 from 9x, I have an x left over, and when I factor out a 9 from 18y, I have a 2y left over, okay? Now, looking at this, I have x plus 2y is in common with my two groups, so I will factor out this x plus 2y. And when I do that, in my first group, I will have, when I factor out the x plus 2y out here, I will have a 4x left over. And in my second group, when I factor out the x plus 2y from the 9 times x plus 2y, I will have a 9 left over. And if you notice, these two are saying the same thing. They are equivalent. It's just that we're doing it in a different order. But remember, multiplication is commutative. The order does not matter. All right, in our last example that we have here, so I'm going to group my first two terms together. So I will write a squared b plus 6abc in one color, and then I'm going to determine what my second group is. And that's going to be minus 7a minus 42c. Now, looking at my first group here, I can see that they have a's in common, and I've got a to the power of 2 and a to the power of 1, so a to the power of 1 is my GCF. They also have b's in common, and they both are b to the power of 1, so b to the power of 1 is my GCF. They don't have c's in common, so my GCF is just simply ab. Now, when I factor that out, a squared divided by a to the power of 1 is just a, and b divided by b is 1, and a times 1 is a, so I just have an a left over here. Again, b divided by b giving us 1 means that they cancel out. Plus, 6 is being divisible by 1 right here, so it's just 6. By the way, my GCF here was an invisible 1 because this had an invisible 1 here, and the largest number you can divide 1 and 6 by is 1. And then A divided by A is 1, they cancel out. B divided by B is 1, they cancel out. And then there's this C left over, okay? Then, looking at my second group, my leading coefficient here is a negative, which means that my GCF will also have to be negative. And 7 and 42 are both divisible by 7, and there are no variables in common. So that's all I have for my GCF. Now, when I factor it out, negative 7a divided by negative 7 is positive 1a. I can just write that I have a left over. Now, negative 42 divided by negative 7 is positive 6. And then I have this c here that's left over as well. This is looking promising. So we've got a plus 6c is in common here. So I can factor out that a plus 6c. And in my first group here, when I factor out that a plus 6c, I have an ab left over. And in my second group here, when I factor out the a plus 6c, I have this negative 7 left over. So I'm going to say minus 7. And this is what you get when you factor by grouping. Thank you for watching this video. If you have any questions, let me know in the comments below or by visiting lulumath.com, where you can also find blank or completed notes for this video. If you found this helpful, please don't forget to subscribe and share with others. Thank you. See you next time.